Okay, so go ahead and reveal these. Hopefully, if you did a perfect circle, what kind of rectangle are you going to get?
Square.
A square. Very good. Find the radius if L is a tangent. Did you look at that and think, oh, it's a 3, 4, 5 triangle? Yeah, it's not, because the hypotenuse is not 10. It's 8. So you had to do a Pythagorean. 6 squared plus r squared equals 8 squared. Hopefully you found that r is 2 radical 7. And then draw all possible common tangent lines. How many did you guys find? 2. 1, 2. Okay. All right, moving on. Incidentally, I'm recording this lecture, so if you say something, be appropriate because it's going to be recorded. Because I had a lot of kids who missed in Latin for the Latin test, so I'm recording right now. Okay, so go ahead and work out this problem, please. The tan of 40 is h over 20, opposite over adjacent, solve for h, 20 times tan 40, which you've given is 0.64. You should be able to do that in your head, but if you couldn't, use your calculator, and you get C as 16.8. All right, so that's a little warm-up. All right, today we're going to talk about central angles and arcs. Okay, first of all, let's remember the definition of a circle, the set of coplanar points equidistant from a given point. A central angle. A central angle is an angle with a vertex at the center of the circle. Okay, so O would be the center of the circle. You would create the angle AOB. That's called a central angle. And then we're going to talk about an arc. Okay, an arc is an unbroken part of a circle. You could have a minor arc, as in a smaller arc, or a major arc, as in a larger arc. The minor arcs are less than half the circle. Major arcs are greater than half the circle. Okay. Well, what would half the circle be? It'd be a semicircle, so it's just going to be a. I guess it wouldn't have it. It would be major or minor. Okay. Incidentally, one thing that we tend to do. So let's say I called. If I put like a little b over here, we describe an arc by saying arc AC. Okay. But you see that if I said for the major arc, if I said arc AC, it might be confusing because you're like, which one are you talking about, the little one or the big one? And so often with a major arc, we'll include a part of the circle that is part of the major arc. So it'll have 3 letters. That's to indicate that this is a different arc than the arc AC that you were talking about. Because arc AC might mean 2 different arcs. That's how we distinguish. Okay? So you'll often see that as sort of a way of describing. Okay, measuring an arc. The measure of an arc is equal to the measure of its central angle. So, what is the measure of the minor arc from this picture? Luke? 120 degrees. Good. And then what would the measure of the major arc be? Quinn?
240.
240. How'd you get that?
Subtracted 180 from 360.
You subtracted 120 from 360. And so you're going to get that. That major arc is 240. So the minor arc is 120. The major arc is 240. All right. Adjacent arcs. 2 arcs are adjacent if they share exactly 1 point in common. In this case, point C is shared by the 2 arcs. So name 2 adjacent arcs. What do you think, Andy?
Arc BC, arc CD.
Good. And so we would draw it this way. Arc BC and arc CD with a little arc over the top. That's how we would indicate those 2 arcs. All right. So I'm going to pause the video right now. You guys go ahead and try to find and name a central angle its corresponding arc. What is the measure of arc DG? Name 2 adjacent arcs. There is more than one answer to several of these questions, except for the middle one. Okay, so go ahead and specify, and then I'll show my answers here in just a second. So you guys go ahead and work those out. Okay, here are some of the answers I got. Your answers may differ. I got angle ABD, that forms arc AD. 2 adjacent arcs I found were ED and DA. Okay, there's many, many options that you could specify here. Okay? So DA would be a minor arc, and then going all the way around, DCA might represent a major arc. I'm just trying to distinguish how you could describe a minor versus a major arc. Okay. So, the arc addition postulate. We haven't had a postulate in a little while. Arc addition postulate says the measure of the arc formed by two adjacent arcs is the sum of the measures of these two arcs. So, if you have angle BAC is 15 degrees, angle CAD is 25 degrees, add those two together, you're going to get 40 degrees. So, you would say that arc BCD is 40 degrees. Now, one thing to pay attention to when you're talking about the measures of central angles of circles and their respective arcs associated. Do you see here how I have two different circles and I have formed right angles, central angles? Okay? Could you say that those two arcs have the same measure? Do those two arcs that I've just indicated with the red lines, do those have the same measure?
Yes.
Yes. Are they congruent arcs?
Possibly.
Possibly. Why or why not?
Because they could have the same radius, and they could.
They may or may not have the same radius. Okay, so let's be specific about what needs to be true for two arcs to be congruent. Okay? Two arcs need to be congruent. Two arcs are congruent if they have the same central angle and they are from the same circle, or congruent circles. If you have two circles that are different sizes, then the arcs are not congruent. They might have the same measure of a central angle, but they're not congruent. Okay? So, that's going to come into play on the next one. Two arcs are congruent if they have the same measure. And I want you to add to this, okay? If they have the same measure, and they're from the same or congruent circle. So if they're from the same circle or congruent circle, then they might be congruent. Notice we have vertical angles, right? Vertical angles, those are congruent. Therefore, the arcs that are corresponding are going to be congruent. These are from the same circle, so we're good. Arc DB and arc AC are congruent arcs. Two minor arcs are congruent if and only if their central angles are congruent. If and only if. What does if and only if mean again?
Exactly what it says.
So you can go back and forth, basically, right? Say if the two central angles are congruent, then you know that the arcs are congruent. If the two arcs are congruent, then you know that the central angles are congruent. Okay, we wrote minor arcs just to keep it so that we're talking about the smaller ones. So we're comparing apples to apples. Good. Fun game. Also like it. All right. And that concludes the lecture for today. So we have 10 minutes left. I think with you guys, I'm going to give you back your tests.